Hi, I'm Rachel Jansen and I'm a member of Patterson & Cook's process group. Today I'm going to be showing you an example of coagulation and flocculation in a slurry sample. Here I have some samples of kimberlite which have been diluted to 1% solids mass concentration. The polymers we're going to be using today is flocculant Mg655 and coagulant MF368. These have been diluted to 0.025% by solids mass. As you can see, the sample is not naturally coagulating. Even when the slurry is left to stand on its own, some particles stay suspended and remain dispersed. When this happens, the sample is said to be colloidally stable. So first of all, I'm going to add some flocculant to my slurry sample using the syringe. I'm just going to do about 1 ml. The cylinder is going to be inverted 3 times to maximize the mixing between the flocculant and the slurry material. I should also mention that gloves are recommended as PPE for this experiment to reduce the contact with the material. As you see, the flocculant has little effect on the slurry sample. Typically, when the correct flocculant is added to a slurry, flocculation occurs and the particles come together to form large flocks which gain mass and settle to the bottom of the cylinder. To improve the settling behavior, we need to coagulate the fine particles. This will allow the fine particles to come together and form small agglomerates. Sometimes we can do this by changing the slurry pH to reduce the strength of the repellent forces between the particles. Sometimes this can be done by increasing the conductivity of the slurry. Another way coagulation can be achieved is by changing the surface charge of the particles by adding a polymer coagulant. Here is another sample of fresh slurry, which I'm going to now add coagulant and then flocculant to. So once again, I'm going to take my dose using a syringe. Okay, once again, I'm going to mix by inverting the cylinder. Now we see that the fine particles are forming small agglomerates and are no longer dispersed. The slurry is now coagulating or coagulated. So this material is now ready for flocculation. Once again, I'll be adding 1 ml of flocculant, so the same dose as we had before. The smaller agglomerates are now forming flocks which, through their increased mass, settle faster to the bottom of the cylinder. As you can see, the water that's being liberated is fairly clear of solids. The preparation of slurry using a coagulant before flocculation can save on flocculant costs and improve thickening performance. With colloidally stable slurries, often slurries containing clays, coagulation is required before thickening is possible.